Hi, this is Dr. B, and we're going to be looking at another type of control chart, the proportion defective or P chart. And unlike the variable control charts, we will only have one chart as our output. And so let's get to work and create that. So the P chart will be calculating P bar, which is the total number of defectives divided by the number of opportunities. We'll actually be calculating P because we're given number of defectives and the sample size. We're not given P, so we'll be calculating that. And then we'll be calculating the standard deviation, which is simply the square root of P bar times 1 minus P bar divided by N, which is the number of observations in a sample. And after we have that, we'll calculate the upper control limit, which is just P bar plus Z times S sub P. If we're not given information about the confidence level, then we'll just assume Z is 3. And that's what we'll do in this particular problem. For the lower control limit, the instructions here are that essentially you don't go negative, that if it's less than 0, then you just put 0. I prefer that if it's less than 0, you don't include a lower control limit. There's some reasons behind that I won't go into right here. All right, so let's get started. So first of all, let's calculate our P's, our proportion defective, and that's simply just the defective divided by N. And so, in Excel, it'll be carrying more significant digits than we are including in the actual cells there in the spreadsheet. And then P bar is, well, it's really the sum of the defectives divided by the sum of the opportunities. So let's calculate that up here. So sum of the defectives and the sum of the opportunities. So P bar is simply defectives divided by opportunities. So that's our P bar. Our S is equal to the square root of P bar times 1 minus P bar divided by, and we could put any one of these cells to give us N, divided by N. And then we close that, and that's our standard deviation. And then our upper control limit is simply P bar plus 3 times S. And that's going to be way below 0. So, well, I'll demonstrate. But so P bar minus 3 times S, and that's a negative number. I've already included a strike through on that to say that's not valid. So now let's put our P bar up here so we can draw a line for it. So P bar is equal to C15, and we want to lock the row in place, and we'll copy that down. But let's go ahead and do the upper control limit. Upper control limit is equal to P bar plus 3 times the standard deviation. And let's make sure we've locked all of these appropriately. So we want to lock this one, and That won't matter. Lock this one all the way down. Let's see. I think we're ready to copy both of them. Let's see. And that's right. Now let's create quickly a chart. So we will highlight this data. Actually, we don't want to plot the defective, so we'll just highlight this data and then insert. And we've got P, which is what we're plotting, P bar and upper control limit P's. Let's change our chart type and use a custom chart. And for P, we'll do this line with markers, and everything else will be just a line. And you might want to play with the coloring and all of that. I've actually forgotten what this particular problem is, so I can't, and I haven't included it. We could have said just P chart would have been okay. And we could add in our axis titles. And this is simply the sample number. And we would be good. This process is in control. There are no points outside the control limits. Having 0 is not out of control. And I think you see the reason why. You probably can't see the whole reason. One of the reasons why I don't like putting 0 as a control limit is it's not proportional. And there are some rules that we use that have to do with proportional control limits. So it could be confusing. You could put a table on this, but we've demonstrated calculating limits for P charts, and then we created a control chart which showed that we're in control, and we analyzed that and stated the results. Thanks. See you soon.